here is our modified zoo simulation. We're taking zoo simulation and I've modified it to do contagion simulating. We're going to change this distancing factor to 1 and the transmission chance is 1, meaning everybody moves every time, so nobody practices social distancing. And if an uninfected person encounters an infected person, they will become infected. Eventually, somebody recovers, and the recovered people in this model can't get sick or infect anybody else. So we're going to put 500 people in our environment. If you look down here, there's the sick person. There's only one sick person for this model, and we're going to run the simulation. And we see rapidly the infection spreading out from its start across most of the environment. Now we're going to clear this out, and we're going to change the distancing factor to 0.25, which means people do only 1/4 as much interacting as they would have. I model that by you only move 1/4 as often. And we're going to put 500 people in again. And there's the infected person over here. And now we're going to run the simulation again. You should see in this one, the infection's spreading a lot less quickly. It's still spreading. And if we let it run long enough, it's going to spread out over the whole environment. But we're giving people more time to recover. And the number of newly infected at each step is lower. It's taken a lot longer for that to spread through the whole environment. So you could think about modifications. We could make the people objects. We could look at what's the chance they get very sick and require hospitalization. You can add in a lot of complexity to this, but this basic model can show the value of social distancing. You can also play around with the transmission chance and look at what if hand washing makes you 30% less likely to pass on the infection, and how would that affect the model? So this is something for you guys to play with. I'm going to put it up on the Schoology page, and you'll be able to run it.